Well, welcome everyone in Textkernel HQ. My name is Boriss, and as you might have heard from my last name, Floor is my sister. Although very both in pink, but that's the only thing in common almost. Textkernel, I can understand that you've never heard of us before because we operate in quite a niche market, I would say. We are in the HR tech space. So what they build here are actually solutions for people like me because I am in recruitment. I work here as a talent partner. So I'm that annoying person on LinkedIn asking or saying that you're a perfect match for based on your experiences. So what we do, well, we do everything AI and machine learning. So we parse resumes, for example, extract information, search and match, all with a lot of engineering. That's also the majority of our company. So this is the first time we host a tech meetup, so I'm really glad that we are able to do that. Drinks, snacks, you can grab. There will be food at the end of this meetup as well. So yeah, that's it from my side.
Thank you. Right, my name is Floor, or you can address me as Barbie as well, for this day. I'm DevOps Barbie on Twitter if you want to follow me. So I'm Barbie all the time. So welcome to the Amsterdam Open Source Data Infrastructure Meetup. It's a mouthful. This is I think the fourth one that we're hosting. I'm really glad that we can host it at Textkernel today. We'll have a couple of talks today. We have a code of conduct for this meetup, so if you at any point in time feel like you're not in a safe environment where you can learn and share with each other, then please let me know. If you feel awkward about approaching me about something, then you can always approach my colleague. Her details are on this slide as well. Well, we have an agenda today. We have two talks lined up by Boriss and by Jelte, and then we'll have some food and networking afterwards. And this is maybe a photo of me and Boriss doing karaoke, so that might also be in the card still today. So feedback is a gift. If you feel like we can improve something, or maybe you want to help host these things or speak at these things, please use the feedback form to let us know how we're doing and if that's something you might want to get involved in. This will also allow me to continue hosting these meetups, so that's kind of nice. We have, so my name is Floor, I work at Aiven. We're doing these meetups among a lot of other things. We are a data platform, so we do all kinds of open source data tools. We host those as a managed solution for you in a bunch of different clouds with a bunch of wonderful integrations and third-party tools in our marketplace. We also have a couple of free services that are free forever, not a free plan, and then you still have to put in your credit card details, but these are free forever. That's what we have for Postgres, MySQL, and Redis. So that's something that is interesting to you. Go try it out. We host these meetups in a bunch of different cities and in a bunch of different countries. So if you ever find yourself in a different country and you're looking for this exact meetup, you can always go to aiven.io/community and find meetups and events that we host across the globe. We also have a forum and a bunch of other ways to get in touch with us. Do you want to say anything else? All right, yeah, we're doing like this little conference thing in London, 12th of December. Might you be there and not at PGCon EU, which you might be. I will be in Prague. So, but if you're not in Prague and instead you're in London, then go to this one. I think with that, Boriss, I would love to give the floor to you. If that's something you're ready for. Awesome.
Okay, so as DevOps leader Barbie says, name Boriss Mejias, or System Top Engineer, that's the name of my body. Actually, this is my human hand that helped me to pass my message about Postgres. The real name is Water Neighbor. Lord of the Winds of Patagonia. Creation is one of the things that we enjoy doing, and that's why we are going to share with you how to create nice software for developers using beautiful databases. So, let me explain a little bit about what we're going to be talking today. I made a pact with Boriss in the waters of Well, you know him, the Canal de Magallanes, somewhere there. He went to the water. We made a promise. I told him I'm going to show you all the secrets, all the friends and foes of the databases, and you're going to spread the word to everybody. The prize is in the afterlife, so he still doesn't know. And we are willing also to share the power of this knowledge. I'm going to give it to you for free, just because we have nice snacks and drinks offered by a nice host for this meetup. So, Patagonia, and part of the pact was actually that Boriss needs to go to metal festivals from time to time because I really like that music, and because I love that music, we enjoy the experience through the waves of stuff. This is the last experience, well, one of the last experiences in Raspop metal meeting. Yeah, we really enjoy this kind of stuff. It's super fun. I mean, I do like this. It's like a pop, and then that's headbanging. And now we went to this stuff, and this festival, for the first time, they have these things called cashless. So you used to, previous festival, pay with money, then you start paying with coins, and now you pay cashless. So everything will go into your bracelet. So you can see here, there's a metal band from India called Bloody Wood. And you can see here the bracelet, it has a QR code. A QR code where your money is, and then you have to go and pay your drinks for the money that first you put in your QR code. Nice. The thing is that, of course, because this is an IT system, it's going to fail. So they put a help desk in a metal festival. Do you humans love help desk? Why do you put a help desk in a place, a holy place for fun and metal music? And you put a help desk. I call it help desk. Okay, so Boriss went to have a beer. You know, there's people used to say like beer is made by the gods. Well, it is true. It is a very easy way to have control over you and make you do funny things. That's why during this meetup we just have alcohol-free stuff, because I want you to really focus and understand what I'm going to tell you in this presentation. Okay. Good. So he went there. He said like, please give me a beer, and then they check on the bracelet. Oh, your money is still not in your bracelet. You have to go to the help desk. Of course, I know how these things work, because 5 minutes before, all the money was already charged. And this is eventual consistency. Have you heard about the term eventual consistency? Okay. This is exactly what happened. So I told him, don't go to the help desk, go to enjoy Tom Morello, because he has elephants on the screen. Tom Morello, one of the heirs of Victor Hara. Nice festival, nice concert. He went back, asked for a beer, and the money was there. Eventual consistency. So, before I continue, I would like to do a small survey to know who you are, because I know who Boriss is, but I want to know who here is. So who do you identify yourself as a developer? You can raise your hand multiple times if you want. Okay, good. Who identify yourself as an operational part? Okay, less people. Who identify yourself as a DBA? Okay, something else? Okay, more developers. Okay, something else is good. More developers than DBAs, that's good, because this message is specific for developers. As a developer, you see your application in a database, and that's it. You write stuff, you read stuff, that's it. But then you have eventual consistency. How come? If you're writing in the same place, but the data doesn't come whenever you need it. So there are some designs that the operational part puts for redundancy so that everything is highly available. So you have an application actually that talks to a proxy. In the proxy is going to be redirecting all the queries to a primary node, which is your main database, which replicate things to the standby nodes. We can do read-only actually. So if you want to escalate this stuff, you actually put two services in front of it, one that is read-write and the other one that is read-only. A lot of developers don't want to know about this, but it's very crucial that you understand the architecture that is behind it. Boriss went to DevOps Eindhoven a few weeks ago, and he asked some of the people, which database are you using? I don't know.
It's a database, come on.
It's a database. Okay, so it could be something like this, but this might not be the main source of eventual consistency. So let's go a little bit further. Once you have these two ways of acquiring the information, because the proxy is going to mess it up sometimes and do that for you, it will be very nice that your application actually knows about this and have actually two channels. One channel for read-write operations and one channel for read-only operations. Why? Because the proxy has to guess all this information, but if you as a developer, you know, take advantage of that. Super cool, because it's going to work much faster. So, DevOps is one of the concepts that we have seen many years already here. And there's always one thing that is missing here, the DBAs. Yeah, so the DBAs kind of not being part of the DevOps movement. We have been discussing this with Jelte also. So the good thing is that now we have very different ways to have the database as a code. Infrastructure as code is now super easy with databases. So let's look at again the architecture that we have. In this case, we are going to do it with virtual machines, for instance. So you typically have your proxy, which is running on bare metal, one of my favorite platforms for doing deployment. Virtual machines there that are treated like a bare metal. How you do the deployment with this? Well, Boriss, he's really politically correct. He will give you like 3 different slides with different possibilities. I don't. I just pick up one, the one that I think is the best. So pick up this one. It's called Trusted Postgres Architect. You have the link there. It's provided by AV, and it's free of use, like nice free license that you can use. It's based on Ansible, and the architecture that you have there, it fits like in 45 lines or something of Ansible code. So it is really code that you can put in your Git repository, and then you can have a pipeline that is going to put this either on bare metal or virtual machines with IP address, or even Docker containers, not as it was our containerized architecture, because for that, you need something better. Kubernetes, of course. Again, you're going to have multiple slides, of course, but then I want to just give you one here. So you do have services that provides read, write, or read only. You also have the Kubernetes workers that can be in different availability zones or different data centers. You have your pods that do all the replication, primary and standby, and then the persistent volumes here for the database and the wall stuff. Of course, you don't just deploy this with Kubernetes, you need an operator, a Postgres operator. There are many there in the market. The best one, the really native one, is called Cloud Native PG, Cloud Native Postgres. Again, open source, you can just go test it. I think the amount of codes for doing this is it's a manifest of 12 lines or something like that. So infrastructure as a code, this is the important thing. Now as a developer, you can say, I want to test this in my Kubernetes part, or I want to test this in my laptop. You just do it, and then you're going to have kind of a model of the real database in play and try to understand what is going on with all these different services. Very important. All right. So let's get back to this cashless thing. I don't think that this was a problem of primary in standby, because that will go much, much faster. And also when you go to the standbys, they cannot write, they can only read stuff. So this thing was kind of a little bit odd. I think this was something like this. 2 different applications. One that is just talking to the bank account and then putting the money into the wrist, the bracelet. And then this will go into one database that will send data to the other stuff, not like physical replication, but kind of event login or stream replication. Actually, in Postgres, if you want to do this, like sending data from one database to another database, which can be something different, you will do it, for example, with division. Yep. There's Francesco Tishet who is doing a lot of stuff like extracting data from Postgres into other systems through Kafka and stuff like that. So this is very nice. Now, I think that the other application, which was here, with the people who was scanning your QR code, was checking this database here that will get the information a little bit later. They finally fixed it at a certain point. There was much less people on the help desk. So, you hear me saying, Lord of the Winds of Patagonia. You may ask yourself, why is he wearing a t-shirt with runes from the Nordic part of the world? Yeah, because this E, or normal rune, represents a horse in the Nordic countries. Well, with the Nordic gods, we usually discuss about fjords. So we like the fjords from Punta Arenas. So this is the place where I made the pact with Punta Arenas, here somewhere there, with Boriss entering into the water, and I bless him with some of knowledge. And here you have the fjords from Norway and Bergen. So we always kind of share pictures and follow each other on the social media. So why? Because I believe that developers, operational people, and DBA have to collaborate and contribute, and then be learning from each other. Don't create silos. Even we don't create silos, even if we are in different part of the world. We can see the map in the background on the very nice map that we have over there. Okay, good. So let's talk about ORMs. This is something that DBAs hate. They really say, if you are searching for where are the DBAs and they're not saying anything, it's like, I love ORMs! And then you're hearing them shouting like, oh, I love it! And it's okay, there they are. And then you can have a conversation with them. Now, ORMs, I think these are still relevant stuff. But why do people hate ORMs? Well, one of the things, and I know what you want to, that will be an entirely different presentation, is that when you're extracting data with your ORM, yeah, you need to know how much data is going to be sent here. So for instance, you want to see you scan the wrist of a metal head, and then you find this number 42, and then you want to get all the objects from that metal head, and if you do it like this, it might be that it actually does a select star from metal heads, and it's going to take all the table up to your application, and then pick up the element 42. That's not good. So make sure that your ORM actually does something like this. Select star from metal heads where ID is equal to 42. So it might be actually that you have to write this like this. So you have to pass get ID equal 42. I don't know exactly all this kind of stuff. I am just know that it's important to know what your ORM is doing. Okay? And if you think about this kind of stuff, it's much more expressive than all these kind of things. So there are some advantages to use ORMs. Now, it is important when you analyze your ORM, and the example that I gave you, whether it's moving all the data up to the application and then doing the filtering, that I think is wrong. I think that the main concept that you have to analyze every time that you look at your ORM, what it's doing, is to place the computation near the data. Yeah? If you also read the book, Designing Data-Intensive Applications, he also goes a lot in this direction. Try to put as much computation near the data as possible. Yeah? All right. So, the next thing I'm going to show you are some pictures from the worshippers that we have in Patagonia. Yeah. Unfortunately, these people died. They were completely killed by not just the Europeans, but also Chileans and Argentinians that needed to use the place there for searching for ground for gold, silver, and also hopefully more animals and chiefs and stuff like that. One of the bad things apart from losing our people is that we also lose their language. So we don't know much of their stories and we cannot learn from there anymore. So whenever you have the opportunity to learn other languages, it's going to be good, not just for people, because you have your limitations if you just stick to your own language. And as a developer, learning a new language like SQL, because it is a language, is going to give you a lot of opportunities to go beyond the limitations of the thing that you just know for your own programming language. Okay? The same thing for the DBAs, understanding what developers do with their languages is also a very good thing. So let's do a little more SQL. This is one of the lively friends, but it's actually a foe in your SQL code. It's very good for experimenting and understanding what it is in that table. So you do a select star from bands where the band is Epica. Epica is a band from the Netherlands. Symphonic metal, very good band. Why is the problem with the star? Because in this version of the table, you will see that it's going to get the ID and the name of the band. But if you ever change the definition of your table, for instance, adding the style of the band, so we are going to have now this, suddenly the same code that you have is returning more columns than before. Imagine how many people update their applications in the mobile phone like once a year. If you want to update your application, and the application is not able to follow the changes in the data schema, it's going to be completely broken. So you have to think about not only backward compatibilities, but also, it's difficult, forward compatibility. Yeah, so your application has to be able to go further. I mean, you humans, how many years you lived? 80 years? 100 years? The last really outage that we had, it was a meteorite that killed all our dinosaurs. I think it was like 65 million years ago. So think big. I mean, application, you need to think about the future. This way, which is much more explicit, it works for both versions of the database scheme. So it lasts longer. It is forward compatible, not just backward compatible, but forward compatible. And if you have another one who wants to read this data, doesn't work backward, but I mean, this one is for the application that are supposed to be working with this kind of data, right? So the message here is for developers. Oh, by the way, try to use the advantages of the definitions of SQL. In this case, for instance, if I have two bands named Epica, I'm going to have a problem because this is my where clause where the band name is Epica. So you can add a constraint here saying like, I don't want to have the primary key to be the band name, because I want to have this ID, which is easier for doing foreign keys and stuff like that. But I also want to enforce that it is a unique name for that. So when you learn a language, you can start going beyond your limitations of your older language that you have. So, advice here. Explicit is better than implicit. This is one of the knowledge that we get from the Zen of Python. You do import this in Python. This is the second one that you get. Explicit is better than implicit. So in this case, explicit is better than implicit. Think about backward and forward compatibility. The forward compatibility is not that obvious, but if you make it explicit, I think it's going to be helpful. Next thing, okay. So we have here a definition of a band. ID, this is the Fire of London. The band is Epica and the style is symphonic metal. Okay? Yeah, fair enough. But now you have Bloodywood, the other band that I show you, and that is from India. They are classified as new metal and folk metal. If you have a text only, what you start doing is kind of CSV style. So you separate with a comma and then you have multiple values. Let's check, for instance, a band from Sweden, Avatar. These guys are classified as melodic death metal, groove metal, alternative metal, progressive metal, industrial metal. I think every album that they have, they introduce a new style. So this doesn't scale, and it's going to be very ugly. So you need to find a solution. If you are a purist in the world of a DBA, you would say, of course, you have to normalize this stuff. You cannot just put stuff like that. So you're going to have a band without a style here, but you're going to put all the styles in a different table, and then you're going to do a table in between which has two foreign keys, going to match a band with a style. So Avatar is going to be multiple times here, and Epica is going to be only once. This will be somebody doing normalization, third form, very normalized and beautiful in one way. But Postgres allows you to do other stuff, cooler. So you have this definition, and you convert this text into an array of text. Dun, dun, dun. Super easy, and forget about this normalization. So what you're going to have is this array of text. All the values are going to be there. And then what you're going to do is you're going to create an index for those array using gin, because gin is good after the middle. Okay? So what is going to be gin is a generally inverted index. It's going to look inside the array, and it's going to extract the values, and it's going to make a table, and from that table it's going to go to all the possible bands that have that style. So it's going to look a little bit like this. You have a table of bands, there are different styles, and if you find a band with a style which is death metal, it's going to point to all the different bands that have death metal. Symphonic metal, only one, two, groove metal, only one. So this is actually many-to-many relationship, which is what you actually have with a different metal style, which violates normalization. However, the important thing here is that this thing is derived from this value. Aha, so that's important stuff, because you're not kind of violating the consistency of your data, which is very important. Your data is super important, so you have to have this. Now, somebody will say that, okay, but what if somebody made a mistake here, instead of putting death metal, put death metal? Yeah, okay, well, you can also have that here. You can also make death metal and death metal there. So it doesn't really help you in that sense. So you have to be careful about which guarantees you are getting with each of these decisions when you're designing stuff. So I like this one, Gene, with arrays there. So arrays kind of goes into already the friends of the post-relational stuff. Some people call this pre-relational stuff because arrays started before data definitions of languages, of databases. But because they were not included in the beginning, they're now called post. And post sounds cool, like post-metal or post-rock. All right, so what is the message here? Denormalize, but only when normalization is a problem. In this case, I think that there was a problem, well, it's a small example, but when you see that normalization is really a problem, then attempt to denormalize and provide better performance and stuff like that. Because if you denormalize in the beginning, it is a premature optimization. And we know that premature optimization is the root of all evil. It's not heavy metal, it's not death metal, it is premature optimization. When I hear this kind of music that's kind of sticky stuff, I call that premature optimization music. The root of all evil. They kind of predominate people. So let's look at some of the music from Avatar. This was a really nice moment when I was watching when Boriss was watching this. So I was with him actually. Everything kind of filtering, the waves kind of we are all made of waves. This is not kind of a philosophical stuff. There are some observatories in the north of Chile that actually observe things with radio signal, not with mirrors, so they don't just get light. They just send signals and then read signals back, and then they can see whether there is calcium or water in other stars systems because the wave that is being sent, it has a special order. So our bones, the same calcium that you can find in different places of space, is just measuring waves. That's why music resonates so much in ours. Okay, so Avatar. I like it very much, so I wanted to rate it. And if I look at this application, where you can see also how much liquid I acquired during the festival, a lot of water, of course. I mean, beer is kind of 95% water, so counts as water, depending on the year, of course. Then you will see that the application, we don't have stars, we have kind of like inverse pentagons. You can rate it like, is it good or not, the gig that I just saw in the festival. Now, of course, this one is going to be a Boolean in your table. A gig for a band in a festival, Boolean, did you like it or not? Like a favorite in other social media stuff. But somebody said, like, this is not enough. Let's put some scores. And then classify them from 0 to 4. How much I liked it, because it's not enough to say that I like it or not, because some of bands are going to like more than the others. So this is going to go from a Boolean to an integer. So you start seeing already again, forward compatibility. How are we going to modify the table so that all the versions of the application can actually understand the data. Now this one said, like, I don't want to have integers, I want to have like 4.5. Because people want to kind of be really, I mean, this one was like a 4.4, this one was 4.9 out of 5. And then later you're going to have the possibility to even add text. I'm going to add a review on it. So we went from a simple Boolean to a lot more complex stuff, even changing data types and stuff. So this is going to be complicated with the normal columns and stuff like that. You can do it, but I would say like this is the moment for adding another post-relational data type in the review process. This one is still a very nice entity relationship system. So a band is going to have multiple gigs and multiple editions of festivals, and then each gig is going to have multiple reviews. And then each review is actually going to be in this table a JSON object. So let's look at this. First you have the band, as we already saw, which has different styles, and it's a unique name of the band. And then you have a gig. And then here it's important to have references to the festival and to the band. Yeah? So this is a way of coming, it's a constraint actually. A value has to be pointing there. The problem with the name constraint is that it sounds negative. It's actually a guarantee. So you see constraints as guarantees. Yeah? This is something very important. And now, banging moments, this is what they were playing, is instead of saying like a start time, end time, or start time duration, you just use this super cool data type, which is a range for time zone, with time zone. So you know when the band started and when it finished. So this is one of the data types that you need to, when you learn more about Postgres and SQL, you will see the possibilities that you have on the tables. And now we go with review. Review is just, well, we have an ID, we have a reference to the gigs, and then it has a JSON object here. Why a JSON object? Because then I can put booleans, numbers, which numbers can be integers or can be decimals, and I can put text. So a review will look like this. I scored this gig with a 0.999. This is actually 666 by comparison, you know. Switching, splicing, source, avatar, etc. But then later I will actually have what was my favorite song of that gig. I just added. I don't need to add a column. So this one has no problem with another application that doesn't have all this column stuff. So I just added to the JSON object, and by reading the keys, depending on the version that I have, I will be able to see more information or less. I will also ask who did the review. The metalhead number 4106. That's actually the room number in the hospital when Boriss' second daughter was born. She wasn't in that room number. I was in the room those kind of moments. Okay, so, but this is wrong. Why is it wrong? Anybody has an idea why this is wrong? You have an idea?
There's no relation.
Exactly. So this one should be there inside the JSON object. So be careful, don't exaggerate, don't put everything on the JSON object just because you can. So we have this kind of nice, beautiful entity relationship model. So let's put the review by a metalhead that has multiple reviews as a foreign key. So everything that falls into the normalized, beautiful way of putting things in tables, put it outside. And then everything that is more dynamic, use it in the JSON. So you go to JSON when your normalization of the relational model is kind of a limitation. All right, so a few tips about JSON before we finish. These are the arrows that you have to use for JSON objects. In the beginning, it was a little bit complicated to me to understand, but let's look at what they mean. So an arrow like that, if you have an object here, and you pass a field, it's going to return an object. So this is always going to be a JSON object. That. If you want to see the content of that as a text, you use the double arrow. So this double arrow is to look inside that object. That's what it means. So when you do a comparison, like this text is equal to the value of this field, then you have to do it like this because you're comparing two different texts. You see, that's the difference. If you're comparing with this arrow, it's going to say that no, because JSON object is not comparable with text. Yeah. Now you have another one which is like, okay, I want to compare actually two objects because you don't know the different versions that you have. One has the favorite song, the other one doesn't. One has booleans, the other one has integers. So is this object containing this other object? And it's going to return yes or no. Yeah. So this is one of the first tips that you need to know for working with JSON objects. Now either use JSON or JSONB. B is the best one, so just use JSONB because it allows you to do some binary stuff like indexes and things like that. Okay, so you can use a path as well to go inside multiple levels of a band, sorry, a JSON object like a band. So in this case, it looks like this. So think about a map, and this is kind of a different street, and this is going to be a path for getting there. Again, one arrow like this, it returns an object, two arrows return inside the object. So you have the object here, a path, and then you're going to get either text or an object. Now the path is an array, like this. So in this object, first I'm going to go inside the bands, and then I'm going to use the first element on that array. Yep, and here is going to be exactly the same, but in terms of returning an object, here is going to return text. You have to convert then the text into whatever value you have, so that's a little bit of a limitation. Now, index injection fields. If you have a single value, use a B-tree. B-trees are also useful for JSON objects. A B-tree is just going to go splitting your values until the branches, and from the branches, the leaves is going to go to the object that you need. So for instance, if you have a band now as an object, and I want to index by name, see, I'm going to index the text inside there. Yeah, double arrow. I can do just a normal index like that. So if you have a single value in your JSON field, just do it like that. But if you have an array, let's say that now instead of having a column with text, we put it inside of one of the fields of the object for the, instead of calling it styles, we're going to use more like a French genre. So you have the band genre, which is an array inside a JSON, but this one is not text. You see, I have to use one arrow, one single arrow. Yeah, because I'm indexing the array entirely. And what is an array? So I'm still using J. Yeah. Right. If you have text, like in the reviews, because I'm starting to put a lot of text and I want to find information about who thought that this band was awesome and all this kind of stuff, then you use an extension called the trigrams. Okay, it's an extension called PG_trigrams, part of the contract stuff, so you don't have to install any special package. It's always there. And you do it like this: create an index, like for an album or a gig, and then you say on the reviews, and then using gene again. But in the gene, we're going to pass this tag here to say like it is going to be gene, but with trigrams options, and this is going to make a map of the text. You see the double arrow here, which is with 3 letters, and with those 3 letters inside the text, it's going to find proximity, and it's going to be super fast. It's very fast. The index itself is large, but if you put this in external indexation, like Lucene, for instance, it's going to be even larger. But this one is going to allow you to search immediately inside the field of your JSON object. I really like it. It works really well. Okay, so I told you about the score. The score that was in the beginning just a boolean, and then we turn it into an integer, and then we turn it into a decimal. Can you enforce that from now on, all the scores that we have are going to be of a certain type inside the JSON field? Because it's not a column. Well, it is possible with an index. So we create an index, a normal index, a B-tree, with the score that is here inside the object of the field, so double arrow, and we pick up this text and we do a cast to double precision. So when we insert the value, if we cannot cast it into double precision, it's going to fail. So we cannot insert any more values that are not double precision stuff. So this is a safeguard for a data type of something that is dynamically typed. I think this is cool. Well, so you see, learning new stuff from the database itself allows you to guarantee the quality of your data. So don't let everything to happen on your application. Some of the stuff, computation, it happens near the data, it's going to be much faster and much more consistent, and you're not going to have surprises later. Closing words. Postgres for developers, because this started like a Postgres for developers stuff. First of all, understand the architecture. Don't be like some of the people that we ask, which database are you using? A database. You can, but if you learn more, you're going to be able to take advantage of that. Derek, for instance, was making a presentation about transactions. And once you understand more, your queries actually run much faster, and the developers are super happy. So if you're a developer and you want to be happy, understand the architecture and understand everything that's going on. Relational design still makes sense. So don't try to do that everything has to be dynamic. As we were looking at, there was a relationship between the metalhead doing the review. We just put it into a column, it's a foreign key, and we get there. It's much better. But practicality beats purity, another wisdom that comes from the Zen of Python. So when you see that normalization is in the way, denormalize and just do whatever is best for your application. That's the most important thing, because your application is the main thing, using your data, and your data is your goal. So, and Postgres has, usually, I know people exaggerate, it's like, hey, how was your coffee? Awesome! Just coffee. It can be really, really good, but in this case, Postgres has awesome support for JSON. So use JSON. It's really awesome. Now, DevOps and DBAs. I started also saying that DBAs have to be more involved in this movement. Understand what the developers need. And I know that some companies are doing a very good effort and then collaborating, doing some ways of setting up ways of expressing the needs in a formal way so that the DBAs can put it into constraints and stuff like that in the database. And don't forget that ORMs still make sense. Not because they are ORMs, be a risk, of course it's that. No. First, try to understand what the ORM is doing, because sometimes it's really good stuff. But when it doesn't make sense anymore, in the same way that don't be a purist about ORM, then you can help fixing it. And when you help fixing it, you have to explore together with the developers the non-relational possibilities. I'm not saying features here, I'm saying possibilities, because it's open up for improvement in your application in general with non-relational stuff. And I didn't say post-relational, because some people call it pre-relational, some people call it post-relational, these are simply non-relational stuff. All right, now the real closing words, now that I talk about understanding each other and everything. From Inga Ginsberg, the universe echoes back. Whatever you do is going to come back to you. So, thank you very much.
Hello. Okay, the mic works. So I'm Jelte, and I'm a principal software engineer at Microsoft, and I work on all kinds of Postgres things at Microsoft. Mostly Citus and PgBouncer, and sometimes a little bit of regular Postgres changes there whenever it's broken in a way that I don't like. So yeah, that's kind of what I will stand here, then I can see speaker notes. So now I'm going to tell you about the future of connection coding in Postgres. And before we get to the future, we have to look a bit at the past, because otherwise you never know where you're going if you don't know where you came from. So I want you all to think of the time before there were any connection poolers. Olden times when it was just Postgres. And then some clients started to connect to Postgres. It wasn't alone anymore. It was able to answer some queries. It was happy. Good times. But then more clients came. And they kept on multiplying. And Postgres got a bit scared. Especially when they started even opening more than one connection. Until Postgres couldn't handle it no more. So yeah, that's why it was time for a savior. For all these nasty werewolves, just like me. A savior that can solve all of our problems. All of our connection problems. Because there's a lot of connection problems. I'm not going to list all of them. This is something, you can look at them later. I'll share my slides. But basically, anything with connections is pretty much bad. If you have too many active connections, it's not good. If you have too many idle connections, it's not good. If you don't have a lot of connections, but you have a high max connection value in Postgres, it's also not good. Long-lived connections are bad, short-lived connections are bad, and short-lived connections are very bad. Basically, that's sort of what the slide says, but everything with connections is basically bad. That's the summary. Connections are hard to manage with Postgres. So that's when the idea of a connection pooler emerged. And the connection pooler, how it works, is you have a client, and instead of connecting directly to Postgres, you will connect to the connection pooler instead. And it will send a query there, like a simple select. And then the connection pooler will open a connection to Postgres for the client. And it will send the select to Postgres. And then when the client opens another connection, instead of opening a new connection right away, give Postgres a little bit of breathing room, and it will wait. It will wait until the select is finished, and only then it will send the next query from the other connection to Postgres. And then it does a few other things. Like one of the other things, very important, it doesn't instantly close the connection when the client closes its connection to the pooler. It will keep this connection cached, so it doesn't have to reopen it, because Postgres doesn't like you closing and opening connections very often. It's one of those short-lived, it's like a short-lived connection issue. And then it can be reused if the client connects to the pooler again. And it says new update, it will send the update over the already existing connection. And then when you wait a long time, at some point, the pooler will actually close its connection. And your Postgres is just silent. So that's sort of the explanation, visible explanation of a connection pooler. So the qualities of this savior, this connection pooler, the one is it pretends to be Postgres. It's very important. If it doesn't pretend to be Postgres, all the clients will work. The other is it limits the amount of connections it opens to Postgres, because Postgres doesn't have many connections. And the last one is it caches and reuses connections. The more it does that, the fewer CPU cycles Postgres needs to spend on responding to a new process, doing all kinds of connection setup and connection closure stuff. It can just reuse those kind of things. Many contenders have since emerged. The oldest one, that's PgPool 2. It's the first, I guess there's also a PgPool 1, but I've never seen it in a while. I can't find it on the internet, I can't find any information about it, so I feel like it's maybe a private thing from some company, and that at some point they were like, okay, well, this thing is, we're building a new one and we'll open source that one. And that's why it's called 2, but otherwise I don't know. But yeah. And that one, it did a few things good and a few things bad. It was the first one, so it can't be, it was better than nothing. But these days, the things that it does is not the best. One of the things that it's a bit fancy, it can parse queries. So if you send a select to it, just like Boriss said, like you can use it to send, like to be a proxy and send read queries to read replicas and write queries to write the right part. But it does need to parse the Postgres queries to be able to do that, which is, I mean, it which uses of CPU and it, I don't know, extra code. It's not super great. And the focus, it has, other than that, there's a focus on HA and load balancing. So it's really meant for this kind of, like, you have multiple Postgres servers and send my queries to the one that's working best, basically. But it's not very efficient with resources because every connection is still like one thread, I think, or one process. It's very heavyweight, almost as heavyweight as Postgres. It's just like a nice sort of sending connections to Postgres. And it does session pooling only. And I'll get to what session pooling is and transaction pooling. Because that's where PgBouncer comes in. It's the tool where I'm a maintainer of, so I'm slightly biased in this presentation, but I mean, who isn't? So this one introduced transaction pooling. I'll explain more what that is. But it focuses on performance. That's like the main thing. It was like PgPool2, slow. Let's make it very, very fast. Let's do as little as possible. Let's not parse queries. We only look at the actual Postgres protocol and do stuff based on that. And because it's also quite old, it has support for lots of niche features that people wanted over the years. Like lots of authentication support, lots of things. Like you probably need like 5 of them, but everyone needs like 5 different ones. And they're all there. So yeah, this thing, it could be run on the same machine as the client. It could be run on Postgres. It could be run on both. You have many different setups. You can run it on a separate machine and use it as a proxy, although it's not the best at that. But as long, I mean, it's good at that, but it doesn't have lots of HA support. So it works best if there's only one main Postgres thing and it sort of knows about that, and not like 5. And you can duplicate them, so you can even do some. I mean, if your one PgBouncer machine is not handling all your load, you can use multiple. And yeah, it was not. This one is also not without problems though. It was not really maintained for a long time. I mean, it was working, sort of. So I mean, maybe it's done. But at some point, it started to show its age. The single-threaded design. So there's only one thread. So if you use your one CPU core to the max with PgBouncer, after that it can't do any more queries, and then you need multiple PgBouncer processes, which is a bit of a hassle to set up. And transaction pooling, which I'll get into next, it breaks prepare statements. Because transaction pooling, let's go back. First, let's say what are prepare statements. Prepare statements, they improve performance when you set the same query very often. Basically what they do is, instead of you running like, this is without prepare statement, the world without prepare statement, you run select and then some ID, select some other IDs, do this all the times. And then Postgres needs to do a lot of work reading this query, basically. Pretty much understanding what you wrote to Postgres. Parsing it, planning it, understanding what tables are involved, what kind of things you want, what indexes it should use. This is all, it's all not for free. So instead, prepare statements, you give it the query, you say, you put like a little variable in there, like $1, and then and you give this query like a name, and then you say to Postgres, look up this query that I gave you with the name. What? I moved too little. We were all way too not moving.
Yeah.
All right. So I should move more with my arms, I think. or be like, all right. So yeah, you pass an argument. It's basically a function in Postgres. You create a function, but then it understands the query. It parses it and plans it only once during the prepare, and then it can reuse that plan and the parsing for all the execution. And that's kind of nice. But then the problem with transaction pooling. Transaction pooling is when session pooling is sort of what we showed before. Is when you have a connection and you only read the connection that PgBouncer has cached, like this one. It's only given back. It's another client or another connection can only reuse it when the first client closes its full connection. And that doesn't happen very often because most clients, they want to keep long-lived connections because Postgres likes that. And PgBouncer pretends to be Postgres, so you want it to be able to handle long-lived connections. So that's why there's transaction pooling. And in transaction pooling, at every end of the transaction, so you do begin, some statements, or maybe not even begin, just a single statement, so like a single select. After that statement, you return the connection back to the pool, and the other client can reuse it. So you don't, like, the actual clients don't claim connections very long. But with prepare statements, that's hard. Because prepare statements, they work at the session level. And I will show, like, you send the prepare, select, well, PgBouncer forwards that, and the client then, like, Postgres then remembers, like, oh, client 1, this connection 1, it only has one connection, I have P1 equals select. That's sort of my understanding of these functions that you just gave me. And then you have another client that says P1 equals update, and then Postgres says, no, I can't do it. It's the same connection, it's the same name. I already know this one. And then this client is not very happy. And after a while, PgBouncer closes the connection. And then the first client even says, like, oh, I want to execute my thing. And then suddenly it's gone. So that's kind of the problem with transaction pooling and prepare statements. So the question is, how do we make this work? And the way to make it work is by tracking stuff in PgBouncer. So you can have PgBouncer doesn't just send through these prepare statements. Instead, it keeps track of, like, connection 1, my connection 1, as P1 equals the select. And I will call that SP1. And SP1, I will send to Postgres, and Postgres will remember that. And then we do the same. We call the P1 from client 2. We call that SP2, and we send that to Postgres. And now everything works, and it's good. So we could do that. And then when we wait again, and everything goes away at Postgres, we still have stuff at PgBouncer. So when PgBouncer receives, like, the exec for P1, first it will tell Postgres what SP1 is, and then it will actually execute it. And now everything works. And the first connection pooler that did this was OSDI, which is another connection pooler, because there are many. And this one is different from PgBouncer. It's a multi-threaded design, so you don't have the problem that if you have, like, one core, it can max it out. It has support for prepare statements. It's written in C, but it's very, very hard to read C. Like, I mean, PgBouncer is also hard to read, and it's also C, but this is like a next level kind of thing. So it's they have their own custom built asynchronous I/O framework in C that's only used there without any documentation. So it seems to work, but it's really hard to do anything new in it. At least for me, I couldn't understand it. And there's two others that more recently, like OSDI is like 5-6 years old, I think, something like that. And these ones, they're like a year or maybe 2 old. And the first one is PgCat. it's also multi-threaded. It's very similar in a sense. It has some overlap with OSDI. I mean, it's also new because everything that's now you build for these kind of things, I mean, it has to be multi-threaded. PgBouncer from a time when like you had one CPU or 2 cores or maybe 3. I don't know, like fancy multi-core. We don't need that. So yeah, this PgCat. The one thing it sort of focuses on is sharding. So you can have you can send sharding keys to it, and in your connection, it will then be routed to the right Postgres. So if user 1, 2, 3, like 1 until 1 million, they're on node A, and 1 million to 2 million, they're on node B. If you set the sharding key to 1, 2, 3, it will go to node A, and if you set the sharding key to something between 1 and 2 million, you will go to node B. And it also does a lot more like healthy node detection, like HA kind of things, just like PgPool 2. But then it's not so resource heavy as PgPool. And it's like a fancy new language, Rust, cool. Everyone wants to learn this thing. I like it, but it's yeah. it also has problems, but it's also fun. But yeah, and it has prepared statement support, but without deduplication, and that's pretty important because this, like, if we go back a little bit, like one thing you can do is one really nice optimization you can do for prepared statements is if 2 different clients send the exact same prepare, you only need to prepare it once on the connection to Postgres. Like if client 1 and 2 they send both select, then you can only have SP1. You don't need SP1 and SP2 because otherwise it kind of explodes the amount of prepared statements you get on Postgres, and Postgres doesn't really like that. And then there's supervisor, which is also new. That is focused on something else again. It's mostly on multi-tenant workloads. They are running like a big, they're running lots of Postgres servers, and they want one big connection pooler that they can use.
It's only there.
It's over there, yeah, right. I was worried that it would come here, that the dark would come to us. I mean, it is Halloween. So yeah, this is focused on multi-tenant, and basically how they do that is they put a tenant, like they have a customer, and the customer has users, and then their usernames, they're like user 1 at tenant 3, or like at Microsoft or something. Like if Microsoft was using their product, we would have our own little subsystem of usernames. And it's written in Elixir, which is even weirder, like a newer, fancier choice than Rust, I think. But it's not very mature, I would say, at this point. I mean, who knows, maybe it will go somewhere. But right now it doesn't have a stable release yet. Cancellations, they merged the PR like last week to have Postgres cancellations work. So if you were sending some heavy query and were like, oh no, I tried to delete all my data, taking forever, okay, good, I can press Ctrl+C or stop. That just didn't do anything, so you just had to wait until it deleted your whole database. And it doesn't have prepared statement support, which is by now the only one of these connection poolers, except for like a PgPool. PgPool 2 I don't really count. So yeah. Then finally, there's also connection poolers in your programming language. So most programming languages, they have some client library, like Python has like PsychoPG2, Java has JDBC, and most of these they have some connection poolers sort of built in. And for like, I would say 90% of the people, that's enough, really. You don't need like some dedicated special application. You just want to not have like every HTTP request, open a new connection, close it again, or keep it open for a long time. You just want something that sort of caches it somewhere And if that's your your web server that has its own little pool of like 10, 20 connections to Postgres, then that's fine. That's good enough. And PgBouncer is alive again, now that I'm sort of working on it. Before that it was less alive. But it was also there were also people working on it, but they didn't have as much time. And now there's also some more support from EDB. Euler is also working a bit more on it. So there's been some push to get the PgBouncer sort of more active again. So now there's some basic load balancing support, but not as good as in PgCat or PgPool, so it still needs lots of work. It's the only connection pooler where query cancellations actually do the right thing, because it's very hard to do query cancellations. I have a whole other talk about this, but it's very hard to do query cancellations and connection pooling together. It's not fun to make it work. I mean, it works now. I'm very happy it works, but it was not fun. It started out like, oh, this is fun to do, and then it was not fun anymore. And it has multi-process support, which is, I mean, it's not multi-threading, so it's not as easy, but you can work around the whole single core thing by spinning up multiple PgBouncer instances and sort of gluing them together by making them listen on the same port and configuring peering, which is one of the things that make query cancellations actually work. And now it works with query pipelining as well, and it has prepared statement support. And it has by far the best prepared statement support of all the three, because I tested it with so many clients, and every client was doing other things that made everything break. And I tested it with the other connection poolers, and the most difficult clients, they weren't, like, there were some weird issues that I fixed in PgBouncer. And I don't remember anymore how, but it works now. So the ultimate question, which one should you choose? And as always, you know the answer. It depends. There's no one right answer. For most people, like I said before, just the one built into a programming language, it's good enough for like 90%. And as soon as you start hitting problems with that, probably you should look at PgBouncer. Or maybe your language doesn't have it. That's another option. And then PgCat, if you want an HA solution, that's probably that's the thing, sort of the more modern HA routing that you can use if you care more about HA than about some other, like, less bugs. I mean, sometimes if you don't hit the bugs, I mean, they're not your bugs, so it's fine. I mean, because it works with lots of clients well. It's just that, I don't know, some don't, but if you don't do .NET, I mean, it's not, I mean, maybe you don't care. .NET is very good at making prepared statements very hard. Others say if you need easy multi-threading and PgPool 2, just don't use it. Just try out PgCat instead. And if that doesn't work, maybe fall back to PgPool. But I mean, keep trying PgCat until it gets better, or report issues. People are maintaining that as well. Like others say, PgCat and PgBouncer, they're all pretty well maintained. And supervisor, I mean, maybe if you care about this multi-tenant kind of stuff, or you want to be like an alpha tester of some cool new Elixir thing, or you want to try Elixir and do some stuff yourself, I mean, can still be a good choice. But PgPool, I would say, don't use it anymore. So then, what does the future hold? Well, for PgBouncer, that's the main thing I know. It's replication connections are going to be supported, so you can do like logic replication through PgBouncer. Probably better HA, because it turns out that many people want that. And zero downtime restarts, so you can do like a nice sort of a rolling restart of your whole fleet. And hopefully much easier multi-core, because right now it's not very easy. it needs, you need to know what you're doing to make it work. It's not incredibly hard, but it's some work. And then long term, I mean, who knows? In 5 years, maybe PgBouncer is dead. PgCat is the winner, or maybe Supervisor is the winner. In the end, I think connection pooling is very hard, and everyone needs different things. And if you need lots of different features, that means there's going to be lots of little bugs, especially if the features they need to do some stuff together. So maintainers are basically the most important. It's the thing that defines where the future of connection pooling goes. So if people keep maintaining PgBouncer, probably that stays ahead a long time. But I mean, it's also C, and C is dying out a little bit. Not in the Postgres world so much, but not many new developers are very proficient in C. So maybe they will work on Elixir, or a supervisor, which is an Elixir or PgCat in Rust. So if there's like 10 developers on one of the other connection poolers, I would say probably that one is going to win. But that's not the case now. And people need to be paid. I mean, people want food and houses and like fun stuff like beers. So yeah, most people don't do this maintaining just for fun. It's also to get money.
What?
Yeah, it's crazy. I know. Yeah. So yeah, and reviewing. I mean, writing code is a lot of fun. Reviewing sometimes not. It depends. And so yeah, maintainers. It's in the end where sort of the future goes. So yeah. Any questions?
Why did you pick up PgBouncer in the first place?
Because we were running it in Azure, and we were having some issues with it. I think the main first issue was that it didn't do. You couldn't change TLS certificates without restarting it, which was very annoying. So that I fixed, and then I wanted to fix something else, like the cancellation thing. And then I noticed that the maintainer wasn't didn't have time, basically. He was just very busy with lots of other work, because he's one of the most active Postgres committers, I think. I mean, maybe not but definitely the top 10, I feel. So, I mean, he was doing stuff on Postgres, and not so much in PgBouncer. So, like, can I be a maintainer? And then he said yes.
Yeah, please.
Yeah, so that's so now I have the whole potato basically. So yeah, that's why, and yeah, and it's fun. I mean, I like networking code, so it's I think it's a fun project. Yes.
So whenever you find a bug in the PgBouncer and so on, do you also test the other proxies or?
No. I mean, the prepared statement was so much work that I did some benchmarking and some also for this. I mean, I did this presentation at PGConf New York as well, so I spent some time sort of comparing a bit, seeing what how they fared in the same, because I did spend a lot of time for the prepared statements PR to test it out with lots of clients and some other people also, and everyone found new bugs every time.
And those tests that you have, is it easy to run for the other ones, or is it very specific?
I think it might not, like the test suite for PgBouncer, I don't think it's very easy to run for the others, because it does set up like, I mean, you can probably modify it fairly easily to make it run for the others, but it's not like one button or something. It's yeah. Did you have a question as well?
If you look at the multi-threading model, do you see that PgBouncer will run into the same sort of limits at some point as Postgres itself?
Jelte, can you please repeat it for me?
Oh yes. So it was asked for the multi-threading for PgBouncer and other connection poolers, I guess. Does it run into the same issues as Postgres with lots of that Postgres does? And I would say no, because Postgres, it needs to do a lot more. And Postgres is also, it's really built as like a multi-process thing. Like all the code, it doesn't want threads. Like it's not it's not built in a way that it's easy to add threads to it. And processes are by definition a bit heavy, and Postgres needs to keep much more state per connection. PgBouncer doesn't care so much about the state. Now it has these prepare statements, but that's about it. Prepare statement and like sort of settings, that's the two things that it tracks per connection. And other than that, it's pretty easy to switch between them. But Postgres wasn't really designed with that in mind, so because it was a different era. So yeah, no, I don't think it would run into the same issues. Yes.
How difficult was it to get started, to pick it up? Do you have a background in C programming?
So I mean, I did C in university, then I didn't do it for a few years, and then I worked on Citus, which is a Postgres extension, and Postgres is all in C. So I did a lot of C there, but Postgres C is very different than most C, because it pretty much has like a garbage collector, so you don't really care about freeing stuff. I mean, that changes a lot about how difficult it is to write C. So PgBouncer is like normal style C, where you actually really care about memory leaks. You have to be quite careful. So it's not, I wouldn't say it's very easy to pick up, but I mean, especially because code is also, it's clever in a lot of ways, but not necessarily very understandable. So while I was working on it, I've also added lots of code comments, sort of at least for myself, to make it a bit clearer. So I hope if you want to start on it now, it's easier to start on it than when I started on it. But I wouldn't say it's very easy yet. All right.
Cool. Thank you. I think he deserves one more round of applause for keeping the mask on. All right, I believe there's food. Thank you all. Let's do food. Yes.